Hey everyone, in this video I want to go over how to add and subtract rational expressions. So let's say we had this rational expression right here, 3 over x plus 5 over y plus 1. So we have these two rational expressions and we have to add them. And very similar to fractions, whenever we add fractions or whenever we add rational expressions as well, they must have the same denominator in order for us to add them. So as you can see, their denominators are different. This one has a denominator of x. This one has a denominator of y plus 1. So since they're not already the same, we have to then make them be the same. So let's move these a little bit. Let's move this. And how do we get them to be the same denominator? Well, again, very similar to what we did with fractions, we are going to multiply each of these rational expressions, top and bottom. So we're going to multiply the top and bottom of this rational expression by the other denominator. So y plus 1 on the top and y plus 1 on the bottom. And then we are going to multiply this rational expression, top and bottom, by the other denominator. So that was x. So we're going to multiply the top and bottom of this rational expression by x. So let's go ahead and multiply them. So 3 times y plus 1. We'll just leave it as that. 3 times y plus 1 over, and then x times y plus 1. Excellent. X times y plus 1 plus, and 5 times x, we could just write 5x over y plus 1 times x, or it's the same thing as x times y plus 1. We could just leave that in the front. And there we go. Both denominators are now exactly the same. So in order to add these fractions, we can just add the numerators. So we'll add both numerators, this 3y plus 1 and this 5x. So we'll add both of them. So 3 times y plus 1 plus 5x over x times y plus 1. And there we go. That is how we add two rational expressions. And I'll show you a slightly more complicated example when subtracting two rational expressions. So let's say we had these two rational expressions we wanted to subtract. So let's separate these, and let's write out 9 over x squared minus 5x plus 6. And we wanted to subtract that by 5 over x squared minus 9. So now, again, in order to subtract them, to subtract these two rational expressions, we have to make both of their denominators the same. And as you can see right here, both of their denominators are not the same. So we have to make them the same. But notice something different about these denominators. This one is a trinomial written in ax squared plus bx plus c form, the leading term of 1 right here, 1 times in the a section. So we can factor this. We know how to factor these types of trinomials. And this binomial on the right in the denominator is a difference of two squares. This is x squared minus 9, or it can also be written as x squared minus 3 squared. So we can actually factor both of these to make this easier. So let's scroll down a little bit, and let's go ahead and just rewrite everything here. So we'll keep those numerators. And let's go ahead and factor this denominator first. And then we will factor this denominator second. Okay, so let's go ahead and factor this denominator, this in blue. So x squared minus 5x plus 6. So let's just write our x plus. And we want to find m and n. So we want to find two numbers that multiply to 6 and add to negative 5. So what two numbers multiply to 6? Well, there is 3 times 2. 3 times 2 is 6. Perfect. And what two numbers multiply to negative, or add to negative 5? Well, we know 3 plus 2 equals 5. That's not quite negative 5, but there's actually another factor. So for 6, 6 can also be negative 3 times negative 2. Since a negative times a negative is a positive, both of these factors can be negative. So negative 3 times negative 2 equals positive 6 when we multiply them. And then when we add them, negative 3 plus negative 2, and plus negative is the same as subtracting, so negative 3 minus 2, really. Negative 3 minus 2. That is negative 5. So negative 3 and negative 2 work because they multiply to 6 and they add to negative 5. They multiply to 6, which is our C term, and they add to negative 5, which is our B term right there. So negative 3, negative 2, let's go ahead and use them. Let's erase these, and let's just go use them over here in our factors. So negative 3 and negative 2. And again, adding a negative is the same as subtracting. So we'll just get rid of this addition right here, and we'll just say we're subtracting them. So x minus 3 times x minus 2 is how we factor that trinomial. Perfect. So we factored the trinomial that's underlined in blue. Now let's go ahead and factor this difference of squares right here. So x squared minus 9. This is the same as x squared minus 3 squared. And we know that this is equal to a plus b times a minus b. What is a? A is this x right here. And b is this 3 right here. So we can rewrite this x squared minus 9, or x squared minus 3 squared, as x plus 3 times x minus 3. And there we go. We factored those two denominators. So now we have 9 over x minus 3 times x minus 2. And over here we have 5 over x plus 3 times x minus 3. But we're not quite done. These denominators are still not the same. We factored both of them, but they're not the same. But now, because they're in factored form, it makes it a lot easier to get them to be the same. Because now all we have to do, instead of multiplying, so we'll start with this, x minus 3 times x minus 2. Instead of multiplying the top and bottom by the entire other denominator, by x plus 3 times x minus 3, because we can do that, but that will get messy. Instead of multiplying by the entire thing, we're just going to multiply by whatever is missing. So they both have an x minus 3. They both have an x minus 3 in both denominators. They share that in common. But this one has an x minus 2, and this one has an x plus 3. So this x plus 3 is missing. Let's go ahead and multiply the top and bottom by x plus 3. Okay, good. And let's do the same thing with the other one right here. So 5 over. So 5 over, and then we'll write the entire thing, x plus 3 times x minus 3. And we're going to multiply the top and bottom. We will multiply the top and bottom by whatever is missing. So in our denominator currently, we have these two. We have x plus 3 times x and x minus 3. What do they share in common? They both have an x minus 3, so there's an x minus 3 in this denominator, and there's an x minus 3 in this denominator. But what is this one? What does the other denominator have that the green doesn't? Well, in the blue denominator, we have x minus 2. And the green doesn't have x minus 2. So we're going to multiply the top and bottom by x minus 2, since we don't have that in the green. So we're going to multiply the top and bottom of both those fractions by those. So 9 times x plus 3, we could just leave as that. 9 times x plus 3, we could distribute, but just to keep it simple, I'll leave it out of the parentheses. over this entire thing right here. So x minus 3 times x minus 2 times x plus 3. Okay, and then minus 5 times x minus 2. Okay, over here, x plus 3 times x minus 3 times x minus 2. Now both of our denominators are the same. They may not be in the same order because this one has x minus 3 first and this one has x plus 3 first. But when multiplying anything according to the commutative property of multiplication, the order doesn't matter. It doesn't matter what order you multiply these in. These are both the same denominator regardless. So this and this are the same because they're multiplying the same things. They both have an x minus 3. They both have an x minus 2. And they both have an x plus 3. So they are the same. And they're all being multiplied with each other. So now that they have the same denominator, we could go ahead and add up, or in this case, subtract the two numerators. So let's go ahead and subtract those two. So we have 9 times x plus 3 minus 5 times x minus 2 over this entire denominator. So x minus 3 times x minus 2 times x plus 3. It doesn't matter which order you write these in the denominator, as long as you have all the terms in there, all the right terms. And that is our final answer. And that is how we add and subtract rational expressions. So I hope this video helps, and if you have any questions, please leave them down in the comments below. And thank you for watching.